So good day everyone, welcome back to our channel. And in this channel, as usual, we discuss math solutions, accounting solutions, economic solutions, physical science solutions, different sciences and commercial subjects. But today we are going to be focusing on maths. We're going to be focusing which is calculus topic, some principles of calculus topic. And the principle that I want us to talk about today is the principle of what is called equation of a tangent. So before we can get deeper into this principle, I just want to remind you that if you are new to this channel, if you just join us today, don't forget to hit subscription button so that when you subscribe, you also be able to receive notifications of the content that we'll be posting from time to time, and also some other topics that we shall be digging deep into. So today, like I said, we are focusing on equation of tangent. So before we can talk about how do we determine equation of a tangent according to this question that I put across here, I want us to take a look at this small graph that I have drawn for you. And in this graph, I just want you to have a background of what is it that we call a tangent. So a tangent is a line, as you can see. I can describe it, or we can describe a tangent as a line that touches the curve from outside. So we're saying this is just a line that touches the curve from outside, and the line should not cut through the curve. If it cuts through the curve, that line, it ceases to be a tangent. So a tangent, it behaves like this, just like the way I have explained to you. So as you can see, we have our t and we have our cubic equation. The tangent crosses at this point. So the tangent also has its coordinate, which is, I'll just put x is to y. So this is the tangent that crosses at x is to y. So according to the equation that we have here, we have f of x is equal to x cubed minus 4x squared plus 2x plus 7. So this is our f of x. But the tangent in particular, it crosses at a point where x is equals to 3. So we just want to have a few steps of how do we determine equation for tangent. So in this case, the first thing to do that we have to do here is to make sure that we need to understand that if it is equation of a tangent is also a line. So whether equation of a line, equation of a tangent, as long as it is a line, we have to use the standard equation of a line. In this case, we shall use y is equals to mx plus c. This is equation of a line, the one that we have here. So in this equation of a line, since our tangent is also a line, we want to understand what are the steps involved in getting our equation of a tangent. So two things that we need in this case. We just need to know the value of m and the value of c only. But for us to get those two values, we need to know how do we get m and what does m represent. In this case, I'll write that m represents what is called gradient of our tangent. So since m represents gradient of our tangent, how do we determine the gradient of the tangent? So I'll introduce step number 1. So step number 1 is to determine m, which is the gradient. So m, since the gradient, is determined by finding what we call dy over dx, or what we call the derivative of x. So let us determine the derivative of x according to this equation. So derivative of x, which is our m, we are going to bring down 3 minus 1 x squared. 4 multiplied by, bring down 2x, 2 minus 1. Bring down, we're going to bring down 1. Since this exponent is 1, we're going to just have plus 2. So we rewrite our derivative of f of x. In this case is 3x squared minus 8x plus 2. So this is our derivative of f of x, or our dy over dx, or what we call a derivative of the function. So since we get the derivative of the function, next step from here, we need to find the numerical value of our gradient. How do we get numerical value? Because m in this case, we can say m is algebraic. That is to say, m has variables in it. So to find the numerical value of m, we have to substitute our x is equals to 3 into this. So which means step number 2 is to substitute x is equal to 3 into our derivative. So we have 3 brackets 3 squared minus 8 bracket 3 plus 2. So when you substitute this, we're going to have basically 3 times 9, which is 27, minus 8 times 3, 24, plus 2. Our answer in this case is going to be equals to 5. So that means we now have a numerical value of m. Numerical value of m, our m, which is our gradient, is equals to 5 in this case. So since our gradient is equals to 5, then the next step is to find the value of c. So to find the value of c, we are going to determine, or we need a common point that is along f of x. But let's take a look at this. Already we are given x is equals to 3, which means the coordinate is not complete. X is equal to 3, there is no y value here. So since there's no y value, what are we going to do? We are going to substitute 3 into the cubic equation so that we can get a corresponding y value to the function. Let us do that. So we have y is equals to 3 cubed minus 4 3 squared plus 2 3 plus 7. So we get our corresponding y value. In this case, our corresponding y value, we're going to press a calculator. Let us press a calculator. Once we press a calculator, this is going to give us a corresponding y value of 4. So we get a corresponding y value of 4, which means we now have a common point along. In this case, the common point x is equal to 3, y is equal to 4. So we have a common point. If our graph was this one, we would say that x is equal to 3, which was given, y, we determine it here, we substitute into this cubic equation, we got our y value, which is 4. So what's next? The next step, we are still trying to get the value of c, which means let's have step 3. So in this step 3, we're going to substitute the common point 3 is to 4, our x and y. We are also going to substitute m, which is equals to 5, into the equation, which is y is equals to mx plus c. Let us substitute. Our y is 4 in this case. Is equals to our m is 5, our x is 3 plus c. So simplifying this with a calculator, this will give us 4 minus 15 is equal to c. Therefore, c is equals to negative 11. So 4 minus 15, c becomes negative 11. So finally, equation of our tangent is going to be written as y is equals to our m, in this case is 5, x, our c is minus 11. So this is finally our equation of our tangent. So following our steps, we have step 1, the gradient. This is how we find the gradient. We have to determine derivative. We go to algebraic derivative. To make it numeric derivative, substitute your given x value into this. You get our gradient is positive 5. from there we said that we need a corresponding x and y value, which is the y value of the function. Since we are given x value of the function, we substitute 3 now, not into this, but we substitute 3 into the cubic equation to get a corresponding y value. In this case it was 4. So from here we now go to step 3, which is the last step. Substitute this corresponding x and y and also gradient, which is 5, into this equation of a line or equation of our tangent. Then finally we simplify everything until we get our equation of a line or our equation of a tangent, which is y is equal to 5x minus 11. So thank you guys, this is all we had for you today. We look forward to see you next time as we pursue more topics.